Hi friends, welcome to my another video. Today in this video, I will discuss about lighting designing for a project. In this video, we will cover the manual calculation for lighting designing, and in my future video, I will discuss about the lighting designing through the software. Manual calculation method for lighting designing will build your concept in order to understand that how the light can be distributed in a given space to achieve the required lux level. So let's start this topic. The formula to calculate the number of luminaire required is N is equal to E into A divided by F into MF into UF, where N is the number of luminaire and E is the luminance level that to be achieved, and it will be by some standard. Here I choose IECC standard. You can choose IES standard, IEEE standard, or any local standard like DY standard or ADDC standard. But all the standard more or less will be the same. F here is the flux output by each lamp, meaning one single lamp how much light it is emitting, and that unit is luminance. Okay, so F is the luminance produced by one single lamp, A is the area which need to be illuminated, and MF is the maintenance factor or light loss factor, and UF is the utilization factor. We will discuss each of them. In order to calculate the number of luminaire, we need to know the value of E, that is how much lux we need to achieve in a given space or given area, and what is the area of that space. We need to know that the light which we are going to install, how much luminance a single light is producing, or in a simple language, how much light is producing by a single light fitting or luminaire. So this we have to know. MF and UF, that is the maintenance factor and the utilization factor, I will discuss later. Now in order to calculate the value of E, that is how much lux level we need to achieve in a given space, we need to know it by some of the standard. Different standard have different lux level for different areas, but these standards are almost same. We will discuss here based on IECC 2021 standard. As per IECC 2021 standard, for different areas there are different lux level. Light can be calculated in two units, lux or in foot candles. We are discussing in the lux unit, so we will focus on lux unit of the light. So like cafeteria eating area, the required lux level is 200 to 300 lux. In same way for classroom, general classroom 300 to 500, conference room 300 to 500, corridor general 50 to 100. So for different areas like hospital, gym, kitchen, laboratory, library, loading desk, locker room, lounge, mechanical room, office private and open, parking, restaurant, railway, stairway. For different areas there is different lux level requirement. What does it mean? Suppose there is a room and this is an office room. Okay, so if we will take a lux meter everywhere, every corner of this room, and randomly we will take the reading of the lux, then the lux level at every point of the room must be between 300 to 500, because we are calculating the lux level in a office. Suppose if we are considering this space is not office but it is kitchen, then the lux level required for kitchen is 300 to 750 lux. So when we will move with the lux meter every corner of this kitchen, then the lux level should be measured by the lux meter between 300 to 750 lux. If this space is corridor, then the lux level measured by the lux meter should be between 50 to 100 lux. So for different area there is a different requirement for the lux. You can easily imagine that if this space is a parking lot, then we don't require brightness in the parking lot is that much as we required in the office area, because in the parking lot we need to only park the car, but in the office area we need to do paperwork, we need to read out some documents. So in the office area we need more brightness, more lights. Okay, hope you understood this concept. Now let us move to our next point, that is the maintenance factor. As we know that with the time the light is giving less luminance, less light. If we are fixing a new light, it is giving more brightness, but with the time it is giving less brightness. It is due to the aging of the light, and it is also due to the dust accumulated on the glasses of the light. So we have to consider this maintenance factor also when we are designing the lights for a particular space. So we can say that the maintenance factors is occur due to the aging and the pollution on the lamps or luminaire. Maintenance factor is a multiplier that express the decrease in the light output. Meaning, suppose this light when it was new, it is producing X luminance, okay, but due to age, due to the pollution on the dust and dirt on the light, now the light which we are receiving, the luminance which we are receiving from this light is 10% less than the actual one. So we can say that the multiplication factor is 0.9, because now 100% luminance when it was new and when there was no pollution on it is X luminance, but due to aging and due to the pollution on the light, now we are receiving only 90% of the actual luminance. So we can say that the multiplication factor in this case is 0.9. The multiplication factor generally lies between 0.6 to 0.95. Generally, the maintenance factor is taken as 0.8, but of course, this will depend on how old light is and how much dirt and dust accumulated on its reflector, on its glasses, on the lamp itself. It will depend on that. But generally, for the calculation, we are taking as 0.8 because we are doing cleaning also to the light time to time. So we are considering the value of the maintenance factor in between that, that is 0.8. But of course, it will depend on the situation, how the light is, how old light is, and how much dust and dirt on the light. Now let us move to the other topic, that is the utilization factor. As we know that for every light, the lux level, the brightness level near the lamp is more and it is decreasing with the distance. So suppose you are working here on the worktop, you are reading on a table, okay? So the lux level which you will find, the luminance level which you will find near the bulb is more compared to your worktop where you are utilizing this light. You are reading the book here, okay? So the luminance level near the bulb will be high, but with the distance it will decrease. So that is called the utilization factor. The utilization factor is lies between 0.4 to 0.6, meaning we are fixing the light at the top level, but we are using this light for our useful work at the down level, okay? Maybe we are sitting and reading the book on a table, then the height of the table is approximately 0.8 meter, but the light which we fix is almost 3 to 3.5 meter. So with this distance, the light intensity, the light luminance is decreasing. That is why the utilization factor is considered between 0.4 to 0.6 when we are using the direct light for the work. Now let us understand Kelvin. As we know that the different color of light or the different brightness of the light we are using for different purpose. We cannot use yellowish light in the study room, okay, and we cannot use more bright light in the study room because the more brighted light in the study room will tease your eyes, and the yellowish lights also will create problem during reading. So for different purpose of light we are using it in a different space. Just for an example, the warm light is we are using in our bedrooms, in restaurants, and 3000 Kelvin light which is giving the soft white glow we are using in hotels, in homes, in lobbies, in retail. 3500 Kelvin light which is giving the natural glow light we are using in executive office, receptions area, and supermarket. 4000 Kelvin light which is giving daylight glow we are using in offices, classroom, okay, showrooms. 5000 Kelvin light which is a crystal white glow we are using in hospitals, okay, beauty salons. Might be you notice that when you buy any jeans or shirt, then you feel the difference when you bring the same jeans or shirt in your home, because the light which is used in the showroom have a different Kelvin, and the light which you are using in your home is of different Kelvin. Because of this different Kelvin light, you find the difference in the color of same jeans in showroom and in your home. So there are many factors involved in selecting of any light fixtures. For example, you will check what is the input voltage for that light. Suppose if one light is taking 100 watt, then you will not go for that light because the 100-watt light will consume more electricity. You will go either for 16-watt or 32-watt light because it will consume less electricity. Other than that, the decisive factor for selecting any light fixtures or luminaire is the efficiency, meaning how much luminance it is giving per watt. What does it mean? Let us take an example to understand this one. You can see that this light is consuming 40 watt, this light is also consuming 40 watt, and this light is also consuming 40 watts, okay? But you can see the difference in the luminance. This 40-watt light is producing 5200 luminance, but this 40 watt is producing 5120 luminance. This 40 watt is producing 4920 luminance, and this 40 watt producing 5200 luminance, meaning the watt is same but the luminance, the light emission from the light is different. 5200, 5120, 4920. So by a consumer, which one you will decide to select? Which is producing more luminance. More luminance means more light in the same electricity consumed. So which one is good for the consumer? Which is emitting more luminance in the same watt. So this is also a one of the decisive factor in selecting the light. The other one is rated service life. What does this mean? What does it mean? Suppose we are choosing a light, but its life expectancy is only 2 months. Means within 2 months it will break down, it will fuse. So you will not go to choose that light because you, if for every 2 months you are have to change that light. So you will choose those light which have more life service, maybe 1 year or 2 year like that. Another condition is size. Suppose you have a room with a very low ceiling. If you will select a bigger light, then the clearance height due to this light will become more less. So you, in that time you will use a flat light, so your clearance height will not affect. The other factor in selecting the light fixtures or the luminaire is the light output. Meaning, suppose if you are selecting a light for an office, then you cannot choose a light which is of 2700 Kelvin because the color of the brightness of 2700 Kelvin is warm white, which is not good for the office work. So you will go either for 4000 Kelvin, 4000 Kelvin, as 4000 Kelvin light producing daylight glow, which is good for the office work. Meaning, depending on the application of the light where this light is going to be installed, you will select the light Kelvin, that is the color brightness of the light. Apart from that, there are many other factors also which is affecting the selection of the light, that is the surface brightness, color characteristic, electrical operating characteristic. We need any other accessories like ballast, compatibility with the electrical system, suitability of operating environment. There are many other factors also which is affecting the selection of the light, but which I explained you in more elaboration. That are the major factor which we have to consider by selecting the light. Okay, now let's back to our original topic. As I told you in beginning, in order to calculate how many luminaire we need to be fixed in a given space, we need to know the luminance level, which is depending on the any standard codes, the area of the given space, and the luminance produced by a single light fixtures or luminaire, which is called F, and multiplication factor and utilization factor. Now I have taken one example. As per our example, we have to calculate how many luminaire is required for a office which having a size of 20 by 15 meter. Okay, so what we learned so far, we will utilize this knowledge in order to calculate the number of luminaires for this office. As we know, we need to find E, A, F, multiplication factor, maintenance factor, and the utilization factor. in order to calculate the number of luminaire. So let's find the value of E. E we will check out from the standard charts, as we are using this luminaire in the office. So for the office we need 300 to 500 lux level. So we will take the higher value. So in this case E will be 500. Okay. What is the area? Area is given 20 by 15, that is 300 meter square. Okay. As I explained you what is maintenance factor and what is utilization factor. As we are using the lights in the office, so maintenance factor will be very low, meaning we will take the maintenance factor 0.8. Okay, and generally for our calculation we have to take 0.8, and the utilization factor I am taking as 0.6. Everything I explained you in detail, what is maintenance factor and what is utilization factor. Now we need to find the luminance produced by a single light. As we know the situation where we have to install the light, what is the condition of the area, so we will select the light by referring the catalog. Okay, as we know we need a light which having a Kelvin value of minimum 4000. Okay, because this 4000 Kelvin light will produce a daylight glow which is good for the office users. Selection of luminaire is completely depend on the consultant or the client. They will refer us that this type of light you need to install. Suppose client said we need this type of light. Okay, so in order to satisfy our requirement, that is the light should be having 4000 Kelvin, then and the watt value will be less, so it is a 40 watt which is under our acceptable limit, then we will go for the luminaire which having the luminance of 5120. So we selected this light from the catalog as per our purpose. Now we know everything. What we need to calculate the number of luminaire, but we know the luminance level as per the IECC code, that is 500 lux. Now we got the F value, that is 5120 from the catalog of the light. A we know that is 300 square meter. Multiplication factor, sorry, maintenance factor we selected as 0.8 and the utilization factor as 0.5. Okay, so we will substitute all the value in this formula. After substituting all this value in the formula, we will get 74 lights required in our office. But here one question arises, that how many lights required in length and how many lights required in width. So this we have to find. Okay, how many lights we required in row and how many lights we required in column. It's same as how many lights we required in length and how many lights required in width. There is a simple formula to calculate the number of lights in width, that is under root n into, that is the total number of light into width of the room divided by length of the room. Okay, this is the width of the room and this is the length of the room, which is 20 meter and this is 15 meter, and we calculated the total number of light 74. Okay, so we will substitute the value. We will get the number of lights in a width is equal to 7.4. It is in fraction, so we will round up it, because we cannot install 7.4 light, we can install either 8 light. Okay, so we will take a round up value, that is 8. So we will put 8 lights in a width, 1 2 3 4 5 6 7 8 light. And in same way we will calculate the total number of lights in a length is equal to under root total number of light into length divided by width. When we will calculate, we will get 9.9. We will round up it, so it will be 10. So total number of light should be installed in length is 10. So 1 2 3 4 5 6 7 8 9 10. So 10 lights in length and 8 lights in width. When we will distribute this one, it will look like this: 1 2 3 4 5 6 7 8 9 10. 10 lights in length and 8 lights in width. 1 2 3 4 5 6 7 8. Okay, we need to obey one simple principle, that the distance between the light will be equal. So suppose the distance between the light in the row is x and the distance between the lights in column is y. So between every lights, the distance should be y in columns and the distance between the rows should be x equal. And there is another rule also, that the distance from the wall of the room to the first light will be half of the distance between the light. So x by 2. Hope you got this one. So the distance between the lights is 20 by 10. There is 20 meter length and 10 lights. So distance between the light will be 20 by 10, that is 2 meter. So we can say that this x is equal to 2 meter. Okay. And this one, the distance between the lights in the column will be 15 meter divided by 8 is equal to 1.87 meter. So we can say that here the y value is equal to 1.87 meter. Okay. So here we can say that the distance between these light is 2 meter, 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 2 meter. So how many 2 meter? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 into 2 is equal to 18 meter. And this distance will be 1 meter. And this distance will be 1 meter. So total 20 meter. In that way, we will distribute the lights in the column also. 1.87 meter, 1.87 meter, 1.87 meter, and the distance between this point to the wall will be half of the 1.87 meter. In this way, we need to distribute the light in the office area. The another thing which we need to consider is that suppose the work top is 0.8 meter where we are utilizing this light in office area. Okay. And the clearance height from the floor to the false ceiling is 3.5 meter. Okay. So the clearance height from the work top to the light is equal to 2.7 meter. Clear? 3.5 minus 0.8, it will be 2.7 meter. Now as we see that the distance between these two light is 2 meter in a row, and the distance between these two light in a column will be 1.8 meter. Okay. 87 meter. The second adequacy check is that the ratio of the distance between the light from center to center, distance between the light center to center is 2 meter, and the clearance height from the light to the worktop, that is 2.7, is less than 1. It always be less than 1. In our case, the distance between the two light is 2 meter and the clearance height from the worktop to the light is 2.7 meter. So of course 2 divided by 2.7 is less than 1. So this adequacy check is okay. Suppose if the distance between the light is 3 meter and the clearance height is 2.7 meter, then it will be greater than 1. In that case, our light distribution is not correct and the number of light we calculated is not correct. So always we have to check that the ratio between the two lights and the utilization of light clear space, that is in this case 2.7 meter, is always less than 1. So we satisfied the two conditions, that is the lights are distributed in an even manner, okay, and the ratio of the distance between the two lights and the clearance height is less than 1. Even if we will calculate this ratio in considering the column, that is the distance between the two light is 1.87 meter and the clearance height is from the worktop to the light is 2.7 meter. So again it will be less than 1. In all the cases it should be less than 1. In that way we can say that our calculated number of light is correct. Okay. I hope you find this video informative and you learn how to calculate the number of lighting for a particular room. I try to give you as much as concept in order to calculate the light designing. In our future video, I will try to calculate the lighting by using the software. If you enjoyed this video, then please press the thumbs up button, subscribe to my channel, and do not forget to hit the bell icon in order to get my new videos update. We will meet in any other video. Till then, take care, keep learning, and bye-bye. Thank you so much.